Good morning, everyone. Wrapping up summer 2020. And you'll notice there's no section number on there because there are two sections watching this identical video, having come to the end of the semester at the same time, 16 and 8-week classes. And we'll talk a little bit about that toward the end here. I am curious in your final discussion post what you guys might think of these, assuming you've had both 8 and 16-week semesters. Few of you are just now beginning with the university, so I assume you've got some experience to share. But anyway, we're going to wrap up the course material. Nothing new. This is just review and some parting final thoughts from me. Um, uh, this is the heart of the course, and reading, learning about these challenges pretty much frames everything. Um, Getting into the literature and understanding how researchers are looking at these problems and how researchers are um, testing the efficiency, effectiveness of these different software solutions. That's the direction you need to go. There's a tendency to think. I didn't like the way this was put to me when I started my doctoral program, but I did find that it to be true. There's a little too much thinking like a practitioner when you start a doctoral program until you really get into the research part of it. It's easy to think of the program like it's a master's degree, like you're just taking this coursework, and the only thing that's going to be asked of you is to learn some more topics. And thinking like a researcher when you're looking at things in this coursework. How would you and how have researchers um, built a project where they actually, had a research question, collected data, analyzed that data, answered the research question, and reported on the findings? There's just a lot of background material, and not enough thinking and reading and like researchers actually adding to the body of knowledge. So yeah, these 5 challenges, and I saw some good participation this week as far as sharing resources. There are quite a few posts out there. Um, Not the best adherence to the instructions this week. A lot of you didn't say why you included them, which was in bold in the instructions. But at least we got the resources out there that you can use in that final paper that's come and due, come and due, come and due. By the time some of you read this, it will have already been due. 16-week semester. The final paper is due Sunday night at the end of week 15. And for the 8-week semester, you get a couple extra days. They give you everything they can, in that 8 weeks. But so the challenge is big data, and I'll throw out some more graphics on this. It's huge and growing, and we'll never catch up to it. But those are our challenges. Um, we talked a little bit about the life cycle. Every data analysis project should start with a question, a business question. Uh, you know, what are the characteristics of a malicious login? Um, what social media trends indicate a downturn in sales? I mean, there's just literally no end of questions that you can ask um, of the data. But you've got to ask the question first. Otherwise, you're just kind of looking at a bunch of numbers. And if you don't ask the question first, it can be it can be easy to come up with the answer before you have that question. And you're kind of introducing bias um, and you're not approaching it to accomplish a mission. That's remember there's a the purpose in everything, um, and asking some sort of business question and then going to find the data that address that business question, um, are uh, the tenets of data science. Now remember, data mining helps you identify sets of data that later your description of or your company's description of in some sort of data dictionary or data architecture document um, might describe to some future data scientist that, oh well, this data shows relationships between different elements that may shed light on a data science question. But these key business roles that we've gone over, you may be one of these already. Some of you are already practicing working in this world. I know a couple of data engineers out there, um, and some of you may not. Some of you seem to be more domain experts. Um, and that's okay because the business user, the project sponsor, project manager, um, all need to have really really deep domain knowledge so that they can help guide the project, and make sure that the folks that are doing the more technical hands-on work stay on track in addressing that business problem. So there's your who. We got the what, the who, the the process, people, process, and product, as Marcus Lemonis likes to say. Um, and then lots and lots and lots of time on data prep in the analytics life cycle. Um, uh, this often feeds back into software requirements. I am constantly feeding software requirements in just my little computer programming school that I run. I find weaknesses in the data. I will ask a business question. Say most recently, what factors of a person's background leads to them getting hired most quickly out of a computer programming boot camp, and I don't have um, fields in my student database that can really address that as thoroughly as what they might. So we have to actually feed that back into the next time the consultant comes out and updates Salesforce for us. Uh, so that life cycle can actually uh, hopefully feed when you operationalize it. It's feeding changes in the way management is looking at things, either investing money differently, cutting programs, adding money to something that's showing promise, changing the way you do advertising, changing the way you work with your clients, um, finding fraud, finding internal problems, internal inefficiencies. So yeah, but I don't know that they focus a lot on models, but don't read too much into that term. A model can just be just a linear regression model, just looking at trend lines. So it doesn't necessarily have to be a machine learning model, like a classifier that's looking at multiple aspects of banking transactions and classifying each one as fraudulent or suspicious or routine. Um, and don't forget about the communicating results. That's why this doctoral program should be such great practice in communicating, and answering the question. As I know, all of you have watched my academic writing for systems engineers. You've watched that video probably 4 or 5 times, right? Because I know I've asked a lot of people to review it over and over again. Answer the question. Focus your writing on the instructions. Focus your writing on what the boss is looking for. Focus the results of your data analysis project on what your client, your customer, the management, whoever you were doing it for. Make sure you're communicating the results clearly, succinctly, accurately, and you're addressing the questions that they answer. Um, and um, that goes for anything you'll ever do, including a PhD program. If you can't write clearly and answer the required subject matter in a discussion or a paper, um, you need to work on it, because that's all PhDs do is read and write, read, write, and conduct research and write about it, and do it again. Write about grants, and grants have very specific requirements, and you know if you just write generally, you won't get grant money. So it's important in every endeavor. All right, that's the life cycle that we all live towards. And the tools, we had some good discussion and writing on the the tools of a data scientist or a good analyst. We talked about personality. Definitely have to be inquisitive, wanting to dig and dig and dig and dig and dig and find how, these interrelationships. You can't just find one, a correlation and be done with it. You've got to keep asking why. Well, why was that? Well, what predicted that? What came after that? What did that factor that we just analyzed? What did it portend for the future? Uh, but you need to be very logical, the way you look at the data, or you'll wind up having researcher bias. Now, you as a data scientist, data analyst, IT person, programmer, probably need to be no probably about it. You need to be logical. You might run into times when sales, marketing folks want to kind of put a spin on things, and that's up to them. Um, you as a researcher, you need to let the data speak for itself. You try not to presume something and then go find the data to choose to reinforce your presumption. That's not scientific. But then, like we said, talking about communication, you got to be expressive. You've got to be able to clearly communicate in words and pictures and numbers the results. And the second bullet, this is my weakness: statistics and mathematics. Um, Data science is unavoidably linked with mathematics, and you don't have to be a PhD in math, but some of this sure helps to have applied statistics. But luckily, if you're like me and you've only had stats 101, and I had a um, quantitative research methods in my doctoral program that reinforced that, and the idea of setting up a hypothesis, a null hypothesis, an alternate hypothesis, and then hypothesis testing, that whole scientific method of quantitative analysis. There's any number of tutorials out there now from very robust sources, where you can catch up and fill in any weaknesses that you might have in some of these tools. And then the good old Python versus R. These are two programming languages that will get the job done. I know my colleague in the math department uh, has been doing nothing but R programming to prove her statistical analysis, and she's comfortable with it, and it provides accurate output. Um, so she uses it, and that's great, and that's fine. And R is used by thousands upon thousands upon thousands of hardcore professional scientists. So that's a good choice. Python is more general. It's even being used as a web framework, business layer language. Um, so uh, as a generalist, I lean towards Python, because I may actually run into it in full stack web development, which is the main thing we do at the Arkansas Coding Academy. Um, And it's kind of your first love. I know more Python than I know R. I took a class in it, play around with it, seen examples. If I were to move, out of management and back onto the keyboard, I would do it in Python. But these are both interpreted languages, so that neither of them are particularly fast in execution, like the same algorithm would be in a compiled C++ program, say. And there are some speed tests out there. I think the Python interpreter, apples to apples, I think the Python interpreter is a little faster. But I get about 30 jobs sent to me a day by an Indeed robot for data science. I've got several robots out there to keep track. I'm not really job hunting right now, but the students that graduate our programs are. So I like to keep track of jobs that are being advertised, particularly in Arkansas, but also online. But I've got a job robot for data science, and they mention SQL and structured data, being able to pull data out of a relational database in virtually every ad, virtually everyone that's just looking for a general data scientist. So SQL is still a big deal out there. And Excel, you even, you're when you first pull up a data set, unless you are really, really good at Python, the drag and drop and keyboard shortcuts in Excel, unless you're working with really large files, then it starts to get pretty slow. But if you're just doing, just business analytics, uh, Excel continues to be a required skill, and something that people are using to get the data ready. Now you can't. It's all manual. That's the beauty of something like Python, is if you're getting a similar data file, um, repeatedly, you can't beat code. Computers do the same routine, repetitive operation excellently. So if there's a lot of human eyeball thought involved in manipulating the data and looking at things and cleaning it up, you know, Excel can be pretty good. But once it becomes repeatable, particularly something like Python or R, really excels if you want to look at the same thing over and over again. But then you've got tools like Jupyter Notebook that let you kind of just iteratively play with the data, bit by bit, piece by piece. So they're also pretty good interactive tools. But anyway, MongoDB, I'm learning this one myself. If you're dealing with semi-structured data, NoSQL is not only SQL. And MongoDB's the top of that one. I think they're number 4 in all databases, maybe number 3 recently. Oracle's still up on top, but then you've got SQL Server, MySQL, Mongo, and Mongo kind of stands apart from those structured databases. So, but data comes in a lot of different formats. So as a data scientist, you gotta get used to those 5 V's, and there's that variety to deal with. And then Hadoop and Spark, the Apache ecosystem. Again, I don't have any hands-on experience with this, but I'm trying to learn more. That's something that really does well in the cloud. Although if you've got a large data center and you want to stay off the grid, that can all be instantiated locally as well. But for big data, individual files that are more than a terabyte, say, um, it's hard to beat splitting it up into multiple clusters and having machines do parallel processing. So if you're dealing with large data sets like that, it can be difficult to get to know on a local host, um, which is what's one thing that's slowing me down. But it can be done. And then of course machine learning, supervised and unsupervised machine learning, and there are so many resources out there if you want to get if you've never done machine learning. I've only done a basic one in Python. Um, it's out there, and all of these tools, this entire world is explorable, learnable, open source. A lot of this you don't even pay for. You don't even pay for this software anymore. I'm not. Open source is just fantastic. So, but those are the major tools involved, and I'm sure there are others. Okay. So I wanted to just go back to this whole big data, a day in data. And this is, like I said, this is several years old, and I use this every class. Hopefully I'll get a fresh one for 2020. Here's one from 17. Every minute of the day. Look at all this. Look at all this data. A 100 million spam emails per minute, and and this doesn't even reflect, now that we're all online and all of our, almost all of our uh, um, socialization now is done via, Zoom and other video chats, and all school has moved online. All How many millions of school children are going back to school, either in person and getting sent back home, or they're starting online. How many kids got sent home in March and went online? Bam! How much data did that present? It's not just load on the network, but trying to make sense of all of that. Now all of a sudden, what had been graded papers that a teacher could just mark on and circle bad things and write the score at the top of the paper and hand it back to the student, and the student brings the paper home and it goes on the refrigerator. That all becomes data now that all these teachers have to deal with. And um, although that was always entered into some sort of online classroom. But anyway, yeah, COVID has definitely pushed a lot of things online. So be curious what a good research project would be. The effect of COVID-19 on, and then pick your research question. The effect of COVID-19 on um, social media advertising revenue, because there's more eyeballs online now, more googling, more people are sitting in front of their computers longer. You could just look at the stock price of companies like Zoom. Shot through the roof with COVID. So there's some research projects right then and there. Not just the human effect, but what was it? What was the overall effect on online, on our online life? Those projects are already in the works. So and then we talked about IoT and just things that are driving this big data that we'll never catch up to. Not until we have HAL 9000s plugged in everywhere that can assemble this data. So the need for data scientists and data analysis software and sensors is growing and growing and growing. Um, but so the tools get smarter, so they say it's democratizing, but I don't know. I don't know. I still think there's an awful lot of training um, beyond just the use of the applications to make all this make sense. And then healthcare analytics, found an infographic, and there's links on the slides to these two infographics. But look at the way healthcare is moving into this something that's obvious for those of you that work in healthcare analytics. So much data being generated, and it's not under control. We a couple of you wrote some really good papers on EHR and EMR, and the challenge in actually getting it assembled, um, from a technical standpoint, from a policy standpoint, a cost benefit standpoint, a human privacy concern standpoint. This is just one domain. I just wanted to throw out like manufacturing IoT. I wanted to then I started finding too many topics. If you look at cybersecurity, the amount of packets across the internet that have to be authenticated, the numbers of keys, the numbers of times passwords are changed, um, the amount of time, the number of software updates that are security related that are released, um, uh, the proliferation of applications that could introduce, look at your app store, the growth of your iTunes and app stores. All of that software introduces potentially vulnerabilities. People are starting to do everything on their phone, so your credit card numbers, your passwords, you know. So anyway, yeah, big data in every domain, in all domains, growing and growing and growing, and we just, I don't believe we will ever catch up. So I did want to talk, since I am currently speaking with two audiences in mind, a 16-week class and an 8-week class. I was curious in this last this final discussion post, as you know, in your parting thoughts on the course, if you've had 8 and 16-week courses, um, what are your impressions of both, the strengths and weaknesses? um, the 8-week course was double the work, but you didn't have a residency. So I don't know if that's good or bad. The residency gets 60% of your grades settled so that you kind of know, where you're going in the course. Not so with the 8-week course. I think the 16-week course, you've got more time to adapt to the topic, more time to adapt to the instructor's um, critique and feedback and what they concentrate on. Some people, you could turn in the same paper that I think is an F. You could turn it into somebody else and they give you an A. Just wouldn't even read it. So 16 weeks gives you a chance to understand if you're dealing with somebody like me that actually reads your papers, or someone that is not. But I don't know that 8 weeks you necessarily necessarily have time for reality to set in and to react to it. Um, and you don't have that residency weekend, so I don't know which one I would prefer, or why or when. We seem to have these buy terms available every term. So I don't know if some of you are doing all 8-week classes to avoid the residency. I don't know, or maybe you don't need the residency for visa purposes. I don't know. Let me know in your final comments. Um, and then what you may not realize is that the 16-week syllabus that I was given by the university had 5 weeks of blockchain, which is one of the majors. The What do they call it? Focus area, concentration. There you go. It's the one of the concentrations in the PhD IT is blockchain, and you're not getting it in the 8-week course, but you did at the 16-week course. And I could have adapted. I take the boilerplate that the university gives me to maintain consistency. Hopefully, among different sections, I think there are this fall. We start next week. I think there are about 8 of us teaching ITS836 in a 16-week semester. So, which is better and why? So, I'd like to hear your feedback in the final discussion post due this week. I wanted to share with you what I call the Sunday night scholar, and I realize, sometimes the week goes screaming by, and you really really intended, on getting into class, and some of you have families, some of you don't. Some of you have PlayStation 4. Uh, those of you that are that have families, I understand. Uh, I I I had kids during both my undergrad and graduate class. My PhD, my doctorate, I got without children. I had virtually no distractions, and it was blissful. But I understand. when you're raising a family and you're working full time and going to school full time or almost full time, it can be tough. But this is your typical. I see this all the time. This is week 5 for the ITS 36 A36 section 8 for the 8-week course. This is week 5. And I see this frequently. Some folks get in on Monday and Tuesday and plan their week, and then you see this giant spike on Sunday night, and I see the discussion board where there's 9 o'clock on Sunday night for the initial post that nobody reads because nobody's online at 9. Certainly not if you're online at 9, you're not reading other people's posts thoroughly. And the replies to fellow students that come 3 and 5 minutes later don't take anything that the student said into account. They're just it's just no value. So I would encourage everybody going forward to help flatten that curve and move that time earlier in the week, no matter what it takes. I would equate your results maybe with your approach. And if you're doing this on Sunday night and it's working for you, then hey, who am I to question it? But this is the 27th was a Monday night. So this is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, PhD day. So there you go. It's not working for some of you, might be working for others, but I just wanted to show you what the data shows. And I don't turn on statistics tracking. Not every professor looks at this, but sometimes I will, and I can see down to the individual person when you're accessing each link. So I will get questions from people that want me to regrade a paper, and I notice that they didn't even watch the lecture until Sunday. So I use it as information, but I'm a crazy person. I am, you can tell me in my week 8, am I more or less involved in class than other? Do I read your stuff more thoroughly or less thoroughly? Am I more difficult or easier grader than other professors? I'm curious to know. And as I've said previously, there is way too much University of Cumberland's material out there on cheating sites. And I'll say it again, cheating sites. Yes, because you're compromising the integrity of the program by sharing your work with the world, because it can only be used to cheat. It can only be used to represent as your own work. If you go out here to these sites and have anything to do with this stuff, you are representing their work as your own, as opposed to just going to Google Scholar and reading the articles and writing it up yourself, um, like I did for 3 years. Um, if you're using this stuff, it's cheating. Look at your syllabus. Read your syllabus. It's all in there. Um, so anyway, and I will say, too much of this University of Cumberland's sharing information out there. Okay. Some final thoughts. So this, data science, big data analytics. I don't believe we'll ever catch up. And I say never because you never say never, but I don't think we'll ever catch up to it. I think it's going to get worse and worse and worse long before it gets better, and it will only get better when we allow or create the machines that can manage the data that they're creating through some AI, and then you get into the whole morality and concerns of artificial intelligence and what the machines would do with that information once it's assembled, what human beings would do once they have an artificially intelligent being. Think, if you haven't seen 2001, 2010, Singularity, any number of the sci-fi, Terminator, sci-fi movies that talk about um, big data and having access to all the world's knowledge. Um, we won't catch up to it. What would a human being ask? And like this was kind of goes back to my week 7 data mining. What would you look into if you could get access to all the data, any data in the world? What would you look into? Um, what would what would humans ask? Uh, where was my grandfather on September 3rd, 2018, or what? I mean, that's out there. If you could assemble the data, it's out there. Um, so yeah, there's just the five V's will continue. We'll keep adding V's. It's going to continue to grow, and it's going to continue. I think you'll see more and more and more specialization within, like we have seen since I've been in IT 32 years, and in the 20 years prior to that, the specialization exploded. I got into IT in the late 80s, and the specialization now has in 30 years is just staggering. There was a time when if you had an account on a mainframe computer and you could write COBOL, you knew everything there was to know about a computer. Back in maybe I don't know, the mid 60s. I mean, I'm exaggerating, but you know it's kind of true. There was a time when there was not anywhere near as much specialization. You were a computer programmer, and there were two languages, COBOL and Fortran. Anyway, like I said, I'm being facetious, but um, as time goes on, um, I think we'll see more and more specialization and more opportunities for professional growth. Now, generally speaking, about the program in general, students need to get into the literature more and understand what you are reading. I see people, posting in class discussion or in papers. In this study, we propose a framework. That's fraud. That is fraudulent. You were not part of a research team that proposed a framework. So when in a paper, when you use their terminology, and you say we, you don't say they, you're fraudulently claiming to be part of that research team. And you need to take this more seriously. You need to know the difference between a case study, a qualitative study and a quantitative study, and a literature review. And if you were reading the literature, really, really reading it, not just using each individual article to try and get through each assignment for each course, uh, you know, just, just, you know, just knocking down each thing that's put in front of you, but actually starting to consume this literature in an organized fashion so that you're moving towards your dissertation. Um, anyway, yeah, get into the literature more and get used to what you were reading. It's easy and it's hard, but get used to it. Which means having bibliographic software and collecting literature, collecting resources. Some of you write on your dissertation fundamentals like you've never heard of the subject before, like you've never heard of a research question. And that's troubling that none of my predecessors ever brought that up, uh, because it's absolutely the most daunting part of a doctorate. You can knock this coursework out, and then bam, now you get to the dissertation. Now what are you going to do? So get used to the fundamentals. Um, Research question, problem statement, problem area, um, and purpose of the research. So that lends towards research methodologies. Um, you need to understand what a research proposal is. As you write the first 3 chapters of your dissertation, you will write them as a proposal. You don't just run out and execute a research project, you have to get permission. You have to pass that through your committee and the college's IRB. You've all seen this in the orientation material, um, but when I see discussion posts and papers that give me the impression that you have no idea what this stuff is, it gives me concern. So get familiar with it. It's all out there. You don't have to wait until you have the coursework. Get out there online and learn what is a dissertation. What's it like? There are all kinds of videos out there that people have posted about their dissertation journal and the challenges of getting their project approved and getting through. So get serious about this stuff. Put some thought into your own research project. There's some of you I could tell that for whatever reason you're in a PhD program and you haven't even thought about what you're going to do your research on. And you I guess you might be able to fake your way through your dissertation and fake your research, but I don't think you will. But some of you are trying to fake your approach in this class. You're posting about stuff that you're not really going to research. So anyway, uh, maybe let me know in your final course evaluation or the week 8 discussion. Am I asking too much um, for you guys to have thought about what you're going to do your research on? Anyway, let me know. And then again, we get down to this, writing originally. Uh, some of you got tore up on this by me and classmates. Um, just this week, I had a student tell me, "Oh, I didn't know you were going to check for plagiarism. I placed that in my paper to work on it." Uh, and that's what I'm getting at when I say you're not writing from scratch. If you're not familiar with that idiom, from scratch, look it up. Um, you need to be able to write about a topic in your own words. I've said this until I'm proverbially blue in the face. Some of you will just not like the result of your Course Hero and Study.com pursuit. And when you place something in your own paper that is someone else's structure, and then you start changing words around, it's still cheating. It's still fraud. You're still fraudulently presenting that as your own work. You have to create from your own brain. Now, of course, you're going to cite statistics. You're gonna cite findings. Yes, absolutely, cite them. But just this week, I found a discussion post that was absolutely copied, cut and pasted, and it talked about in the next subsection we discuss something, or it's like so obviously cut and pasted that it makes you want to puke. But there you go. Um, some of you want to get called doctor to reach the pinnacle of education by cutting and pasting somebody else's stuff. I just, yeah, literally, physically, I have a physical, visceral disgust for that approach. So if writing is not in your strong suit, work on it. Get help. There's and not just, well, gosh, I thought I got a good score on Grammarly, because you can turn in a grammatically correct pile of dung. It doesn't necessarily have to make sense. The topic, the thesis sentence, doesn't necessarily highlight the topic of the paper. Your topic sentences in your paragraphs don't have to make sense. You can repeat garbage over and over and over and over and over randomly and still have a great Grammarly score. So that's not what we're talking about. Um, get help if you um, If I have posted, what does that mean? To anything, if I have highlighted a sentence in your paper and asked you, what does that mean? Uh, you need to get help. Uh, I didn't. I didn't do that unless it was just really bad. I mean, just really, really bad. So if I have posted that in one of your papers, enroll in remedial writing, get a tutor, a coworker, but get help if writing is not your strong suit. But I've posted a lot of material in this class, both sections, that if you just invest the time and do what I tell you to do, it'll fix it. Just writing from an outline, picking your thesis sentence, picking out your topic sentences, writing originally, in your own words, um, about the topic. It will likely fix it. It's the Frankenstein paper assembled from the dead body parts of journal articles, that gives people so much trouble. So yeah, I'm entering now my fifth semester with University of the Cumberlands this fall. So couple of hundred students. So it's getting to be where the information isn't anecdotal, and my observations are not, knee jerk. Um, this program could be fantastic, and it can be destroyed, by the people involved, faculty and students. So um, I would I would part on that note. The future is yours.